Bear with one sec. I'll get this set up. Alright, welcome guys. My name is George Dossett, and today I will be taking you through A1 of biomechanics, which involves both speed and velocity, as well as covering some of the basic terminology and what scalars and vectors are. So first off, we're going to look at the types of motion. And in motion, and in biomechanics, there are three main types of motion. These are the ones on the right in bold. However, linear motion can be divided into two subdivisions of motion, which are rectilinear and curvilinear, all of which we will cover later in the slide. So a simple overview of what motion is simply, as you can see in this definition, it's just the instance of an object changing place. So anytime that there is movement of a system going from one place to another, that is what we class as motion. So first off, we're going to cover linear motion. So linear motion is defined as any motion along a straight or curved line. So this is where the two subdivisions come in. So any motion along a line. So rectilinear motion is the basically motion of an object or a system along a straight line. So this means that there is no change in the direction, and speed and acceleration are all constant throughout the movement. In this photo example, we can see a volleyball player spiking the volleyball down, and the object performing rectilinear motion is the ball as it goes directly to the ground of the opponent's side. There's also curvilinear motion, which is motion similar to rectilinear, however it is on a curved line. So acceleration and velocity are both still constant, as well as the direction, however the motion is just on a curve instead of a straight line. The second type of motion we have is angular motion. Now this just refers to any motion around a fixed or moving axis. So the two examples we have here are a gymnast performing a sort of somersault, where we can see the axis is where they have put their hands as they flip over that. And for the cyclist, this has two examples of angular motion, both in the axis of the wheel, where it moves around the center point, and the axis of the pedals as he moves in a circular motion, in an angular motion around the fixed point of the pedals. So angular motion can be on a fixed point, as these two examples show, or it can be on a moving point, which brings us onto general motion, which is a combination of both linear and angular motion. This means that although an object may be spinning on an axis, that axis is moving in either rectilinear or curvilinear motion. For example, this bowling ball, we know will be spinning as he throws it. However, they usually throw it on a curved path to get a better strike. So this will be a combination of both curvilinear motion and angular motion. Next up, we're going to look at mass and weight and what the difference is. So mass is defined as the amount of matter a system possesses. So how much of something that there is. It is measured in kilograms and equates to the density of a system multiplied by its volume. So if the density remains the same, but an object is bigger, then it will have a greater mass. It's a scalar of a quantity, meaning it has no direction. We will get back onto scalars and vectors and what the difference is later. Mass in a body or body part includes everything, not just their muscle or fat. This means that different athletes have uses for different masses, such as a rugby player or a rock climber, using different masses, which we go over later on in the PowerPoint. We go on here actually. The uses in sporting, a player greatly has their ability changed based on their mass, depending on their sport. For example, a rock climber would require a minimal mass. However, they want as much of that mass to be muscle and as minimum of it to be fat. This is because a greater mass means they will have to put in more energy to go up the same wall because they are carrying a greater mass. However, in a game of rugby, a greater mass will help boost their momentum, meaning that they can tackle harder when they are running at the same speed as someone who is lighter. Now, weight is different to mass, although they have very much got similarities. Whereas weight is the mass of a system, which is a body or object, multiplied by the gravitational acceleration pulling down on them. So gravitational acceleration just means the force of gravity acting down on an object. So for Earth, the gravitational acceleration is 9.8 meters per second squared, whereas on other planets, there is a different gravitational acceleration. However, we don't need to learn about that, as athletes only take part in sports on Earth, funnily enough. This means that when calculating a player's mass, though, you then multiply what their mass is by the gravitational acceleration, which is 9.8, to find their weight. And weight is a vector, meaning it always has a direction, and that is always going down towards the Earth, as we can see in this diagram. An athlete whose mass is 80 kilograms has a weight of 784 newtons, because that's what it is measured in, and that is acting down on the Earth. Now we can cover what scalars and vectors are and what the difference is between them. So a scalar is just a quantity that measures only magnitude, while a vector measures quantities of both magnitude and direction. So simply put, a scalar measures the strength of something, of a force, whereas a vector measures both the strength and the direction of its occurrence. So examples of scalars, we have speed, distance, and mass. These are all scalars because they only show you the strength or the kind of energy output that this has. So for example, speed is in meters per second or miles per hour or kilometers per hour. Distance is in kilometers, and then mass is in kilograms. However, none of those provide a direction. Here are some examples of vectors, which are very similar to their scalar counterparts on the left. So velocity pairs very nicely with speed, as it also measures the kind of movement of an object over time. However, it also requires a direction. So that can be north, east, south, or west, or it can be positive or negative. Displacement, similar to distance, however, again, has a direction, and the same is true for both the difference between weight and mass, as weight is a vector, as we just previously covered. So now we can look at speed and velocity, which is kind of one of the main focuses of this PowerPoint. Speed is the measure of how far a system will move in a set period of time. It is measured by dividing the total distance travelled by a system over the total time taken, which we can see on this equation triangle on the right. Speed equals distance over time. Now in sporting, speed is very useful as it helps calculate how fast an object or an athlete is, which is very useful when training for athletes who need to run at high speeds or need to be able to make sure that they can keep up with competition. Or for objects, as it can show you where they're falling short for throws, for example. A faster throw will result in a long distance. However, they cannot tell you with a general, like with an average speed. This will not tell you whether an athlete starts off far too fast or too slow. This is where splits come in. Now, splits are just distance intervals. For example, say you were covering a 200-meter sprint. By using 50-meter splits, you can measure the time that it takes for an athlete to cover each 50 meters. Now, this gives you an average speed for each 50 meters instead of 200 meters, and you can see in which split their speed is the highest and the lowest. So say if they start off really fast and then really slow, you can analyze this and you can tell that the athlete started off too strong, which resulted in them failing in the end and slowing down, which will cost them time in the race. Velocity is the same as speed, however, in the fact that it measures the distance over time. However, it also includes direction. This means that it has a greater use in sporting, as it shows you negative values, such as when you're going in a swimming race and you go forwards and then you go back that same path. That will result usually in a velocity of 0. This makes it much more specific and gives you a greater variety of use for it, which is much more useful when plotting graphs and measuring speed. Thank you very much. This was the end of the PowerPoint. This is A2, which we will cover in the next slide. I haven't included a bibliography for this one because it's all on the end on A4. Thank you very much for listening, and I'll see you next time. Oh, fuck that, bro.